Okay, so this is a diagram that I kind of filled out and talked about in another video, which was just focused on the structure of the heart. But what I'm going to do in this video is I'm going to focus on the cardiac cycle itself, all right, and talk about what happens during the cardiac cycle. Okay, so the cardiac cycle, as it says, it's a cycle. And the idea is that, so you should already understand how the blood moves through, right? The idea that it comes from the body, from the vena cava into the right atrium, then the right ventricle goes to the lungs, picks up oxygen, drops off CO2, comes back via the pulmonary veins, goes into the left atrium, goes into the left ventricle, and then leaves via the aorta to go to the rest of the body and cardiac muscle and things like that, okay? And so that's how the blood moves through, right? But in terms of what's actually causing it to undergo that movement, that's the cardiac cycle, okay? And the cardiac cycle, as it said, is a cycle, all right? And so the idea is that you have atrial systole, and then you have ventricular systole, and I'll explain what these words mean in a second. And then you go into diastole, and then back to atrial systole. So there's three main parts to the cardiac cycle, okay? And the idea for this is that, so systole is just a fancy word for contraction, all right? And so the idea is when I say atrial systole, what I mean is the atria are contracting, both on the right and left sides of the heart, okay? So it happens simultaneously. So the idea is that you have the atria contract, and that forces blood into the ventricles, then the ventricles contract, and that then forces blood into the pulmonary artery and the aorta, all right? And so the idea is that this is the cycle, but what you'll see, so diastole refers to a relaxing. That means the cardiac muscle is not contracting. So sometimes you will see the idea that during atrial systole, for example, the ventricles are actually in diastole. So you have ventricular diastole here. And the same thing down here, when the ventricles are contracting, you have atrial diastole. And then this diastole refers to the entire heart relaxing for a fraction of a second, all right? So atrial systole, as I said, the idea is that the atria contract, and what that does is it forces blood. So for each of these, you should be thinking about where does the blood flow and what is the status of the sets of valves. So the atrioventricular valves, the AV valves, as well as the semilunar valves, okay? So the idea is when the atria contract, what that does is that it forces blood to flow into the ventricles, I should say. Okay, and if that's going to happen, if you're going to have blood going from here to here, then obviously the atrioventricular valves must be open. So the idea is that the AV valves are open, and they already are open, okay? Just so you know, they don't open during this time. They already are open. They actually open during the latter part of diastole, and I'll get to that in a second. And the semilunar valves are closed. Okay, so now the blood, right? So the idea is that you've contracted the atria, and that's moved the blood from the atria down into the ventricles, right? And then you have ventricular systole, and so the idea is that then the ventricles contract, and when the ventricles contract, the first thing you need to understand is that the AV valves have to close. Otherwise, the blood would just flow right back into the atria, and you're not getting anywhere. Okay, so when the ventricles contract, the AV valves will slam shut. Okay, and the semilunar valves open, because again, what you're doing is you're forcing the blood into either the aorta or the pulmonary artery, and so these semilunar valves that are moving into it have to open. Okay, so that's your ventricular systole, and then diastole is neither the atria or ventricles are contracting. The whole heart is relaxed. Okay, and so during this time, the idea is that, so the semilunar valves then close, because again, if the whole heart relaxes and these are not closed, then the idea is that the blood would just go right back into the ventricles rather than be moving through the arteries. So you want to make sure that, well, you don't want to make sure, but how it works is that the idea is that because you've now forced the blood into those arteries, then when the whole heart relaxes, these slam shut so that the blood cannot flow backwards into the ventricles. So the semilunar valves close. Oops, sorry, valves. All right. And then the AV valves are closed at first, but what happens during diastole is that blood slowly starts to enter the atria from the pulmonary vein and the vena cava. And so during this time, the AV valves actually do open. Okay, during this time. So it's not like they're already open at the beginning, but they do open during the diastole. And so you get blood kind of trickling into the atria. And then once the pressure is high enough here in the atria, then these open and the blood starts to flow into the ventricles. All right, and then the whole process starts again. So the idea with this, is that the process is quite straightforward. Maybe I shouldn't say that, but I think it's quite straightforward in terms of understanding the process. The thing that seems to trip students up are the graphs that come up of the cardiac cycle, okay? And so I just want to add, I'll show you a graph in a minute and we'll talk about it, but I just want to add a couple things here, right? So when the atria contract, what you should understand is that that's going to, they increase in the pressure, okay? And the same thing here, when the ventricles contract, which I realized I never actually wrote down. So the ventricles contract, and that increases the pressure in the ventricles. Okay. And then during diastole, the idea is that so when the ventricles contract, that presses the blood into the arteries. And so then the blood pressure in the aorta and the pulmonary artery are also going to increase because you're squeezing the ventricles and forcing blood into those arteries. And so that's going to cause an increase in pressure there. And so right before I show you the graph, the only other thing I want to say is that the idea is you should know that the valves are opening and closing, like understand during which part they open and close. But the reason why they are opening and closing is always the same, okay? Valves open when the pressure behind them is greater than the pressure in front of them. And I'll demonstrate this on the picture in a second, okay? So when the pressure behind is greater than the pressure in front. And remember I said valves only open one way, right? That's what the tendons are for, to make sure they don't invert the other way. So the idea is that, so valves open when the pressure behind is greater than the pressure in front. So what does that mean? So let's look at this. That means that when the atria contract, that increases the pressure in the atria, and now the pressure here is greater than the pressure in the ventricles, so these valves will open up, okay? But then when the ventricles contract, the idea is that valves close when the pressure behind is lower than the pressure in front. Is lower. Okay, and so the idea is that when the pressure is greater behind, so when the pressure is higher here in the atria, when you're in atrial systole, these are contracting and the pressure is greater. Okay, great. So then these open and flow into and the blood flows into the ventricles. But then when the ventricles start to contract, suddenly the pressure difference is, the pressure here is higher than the pressure here. Right? And so what that means is that these are going to slam shut. And it's the same thing for this. When the ventricles contract, right, that means that the pressure behind these semilunar valves is now greater than the pressure in the arteries, which means they will open. However, as soon as the ventricles start to relax some, now the pressure behind them is lower, and so they will close. Because the pressure in the arteries and is now higher. Okay, I hope that makes sense. I'm going to leave this here. So you can say it either way. You could say the valves are open when the pressure behind is greater, or when the pressure in front is lower. It doesn't matter how you say it, as long as you understand this idea. Okay, so now I'm going to show you a cardiac cycle graph, and we're going to talk about kind of applying this to the graph. All right, so here we go. Here is the graph, and this is a very typical one of what you could see. It's even got the sounds, the lub-dub that you hear when you're listening to somebody's heartbeat. And so I realize this doesn't have colors, so I'm just going to do some. So I'm going to talk about each one and add a color as I go. So let's talk about this lower one first, okay? So here, and then you have a little spike here. So this bottom one that kind of stays very low the whole time, this is the atrial pressure. Okay, so that's here. And the idea is that you can see there's just a small increase in the atrial pressure during atrial systole. So this part here is atrial systole. Okay, and then here it has labeled the AV valves close right at the end, okay? And that closing is what gives that lub sound, that first lub, of the lub dub, lub dub. So it gives the first sound of the lub, okay? And then the idea is that you have atrial systole, and then you have the ventricular pressure. You can see this is the one, it goes up a little bit during atrial systole as well, right? Because as you're pushing the blood into it, it's gonna undergo a slight increase in pressure. But then the contraction of the ventricular of the ventricles causes a huge increase in the pressure, okay? And so that's here. And so this part, when it starts to go up from when it goes back down, this is the ventricular systole. Okay, and again, you can see here, sorry, so, and then the AV valves open as soon as this pressure goes below the atrial pressure, which is what I was talking about here, right? The idea that the valves are going to open when the pressure behind them is greater. So as soon as the atrial pressure becomes slightly higher than the ventricular pressure, then these valves will open, and that happens during diastole. Okay. Now, the other thing, the other one that they've shown you here is the aortic pressure. All right. So this is, since it's the aortic pressure, you know they have to be talking about the left side of the heart, but the pressure changes would be the same for the right side of the heart as well. Okay. Perhaps not quite as large on the ventricular pressure because the right ventricle doesn't have quite as much muscle in its wall. It doesn't have as much of a thick muscular wall, but the idea would be the same. Okay. So then this here, you can see this one that comes up and then down, back down. This is the aorta, but again, it would be the same for the pulmonary artery. And the idea is that, again, as soon as the pressure in the ventricles is higher than the pressure in the aorta, then those semilunar valves open. Okay, and then as soon as it drops, the ventricular pressure drops below the pressure in the aorta, they close again. So again, that's what I was talking about with this. All right, and then the semilunar valves closing, that's what gives it the second sound. All right, and the lub dub is right, and then the idea is that this part here, before you get to the next contraction, this would be your diastole. All right, I don't have a color for that. So this is the diastole. Okay, so you have atrial systole, you get this small increase, kind of small bump in pressure from both of them. Ventricular systole is when you get this huge increase in the ventricular pressure because there's a lot more muscle there to contract a lot harder, and therefore the pressure is going to increase a lot more. And then you have the aortic pressure, and so you can see when the valves open and close on that as well. It is important to note, so after each one of these, when the valves close, you get a little bump in pressure. It's important to note that the actual closing of the valves happens at the bottom of the first. Like, don't try to make it at the top of these little bumps. That's not right. You want to make sure it's at the bottom of each of these. Okay, so that's the cardiac cycle.